Hello dear students, I hope you are fine and doing well in your studies. Students, today we are going to start from where we have finished in the previous session. Student, in this session, we will do some basic questions, examples, theorems, which are important regarding to this chapter. So, let us begin with the chapter itself. Students, let's begin with representation of a relation. A relation can be represented by four forms: roster form, set builder form, arrow form, and lattice form. First of all, we have to study roster form. In this form, a relation is represented by a set of all ordered pair belonging to the relation. Let A is a set -1, 1, 2 and B is a set containing 1, 4, 9, 10. Let a relation R from A to B, or you can say set A to set B, define such that A square equals to B. What is the meaning of this? If we put A here, then the value of B can be obtained by squaring of that. Let A equals to -1. Then B will be -1 square. It will be 1. That's why relation in the roster form can be represented as -1, 1. If A equals to 1, then B will be 1 square, means it is 1. That's why second ordered pair will be 1, 1 and third order pair will be 2, 4 because third element is 2. This is the basic form, or you can say roster form of a relation. Now let's see second form. It is the set builder form. In this form, the relation is represented as a set such that it is the collection of A, B and their definition is denoted here. For example, let A is this and B is this and relation is represented by this. This is called the roster form, and we have to convert this form into the set builder form. In set builder form, there is some notation, or you can say some statements which relates elements A with the elements B. Now here you can see that relation R for this example can be written as in the set builder form A, B such that A belongs to A, B belongs to B. And what is the statement of the relation? A is 2 less than B, means if A is 1, then B will be 3 because A is 2 less than 1. B is 5, A will be 3. If B is 7, A will be 5. And if B is 9, then A will be 7. This form is called the set builder form. Students, third form of representation of a relation is by arrow diagram method. In this form, the relation R is represented by drawing arrows from first component to the second component of all ordered pair belonging to the relation. Let's see example for representation of arrow diagram methods. Set A contains 1, 2, 3, 4. Set B contains 0, 2, 4. The set is represented by the diagrams here in the arrow diagram methods, and according to the definition of the relation, first of all, we can convert this set builder form into the roster form, and by the help of the roster form, you can easily understand the arrow diagram form. The roster form is 1, 2 because 1 is less than 2, and 1, 4 because 1 is less than 4, and 3, 4 because 3 is less than 4, and 2, 4 because 2 is less than 4. The first elements come from the set A and second elements come from the set B, and 0 is not related with the any elements of set A. As we know, the relation is less than. Now this relation can be represented by arrow diagram methods. Elements of A are listed 1, 2, 3, 4. Elements of B are 0, 2, 4. 1 is related with 2 and 1 is also related with 4. 2 is related with 4 because 2 is less than 4. Similarly, 3 is related with 4. This is called the arrow diagram methods, or you can say arrow representation of a relation. Now students, fourth type is the lattice form. In this form, a relation can be represented from set A to set B by the darkening the dots in the lattice. And what is the lattice? Lattice is similar to the coordinate system, or you can say coordinate plane. As we know, in the coordinate planes, numbers are listed here. It is the positive x-axis, it is the negative x-axis, it is positive y, it is the negative y. Let's see example which we have studied in the previous form, or you can say in the arrow diagram form. Example is similar. The relation in the roster form is also same. 1, 2, 3, 4, 2, 4 and 1, 4. Now, this relation can be represented in the lattice form. For this, we have to dark the dot corresponding to 1, 2. Here is the 1 on x-axis, 2 on the y-axis, point is here. 3, 4 will be 3 and 4, let 4 is here. This is 3, 4. 2, 4 will be here. And 1, 4 will be here. This darkening the points is the lattice form of representing a relation. Students, let's see one example. Here is a given figure, shows a relation between the set A and set B, and this representation is the arrow representation. Now we have to write this relation into the roster form and set builder form. What will be the roster form? As we see here, the element 9 is related with 3 and -3. Then in roster form, we can write 9, 3, 9, -3. For the element 4, or you can say second element, 4 is related with 2 and -2, and 25 is related with 5 and -5. This is called the roster form representation of the relation. Now, in set builder form, relation can be represented as a ordered pair such that first elements come from set A and second elements comes from the set B. And here is a definition. What is the definition? It is the relation between first elements and second elements. You can say the first elements A is equals to B square, because square of 3 is 9, and as we see here, square of -3 is also 9. That's why this is the representation in the set builder form. What it is, students? It is the roster form and it is the set builder form. Students, let's see total number of relations. Let capital A and B be two non-empty finite sets having P and Q element respectively. Then from set A to set B, what are the total number of relations? Means it is the set A, you can say, it is the set B, and set A contains P elements, means n equals to number of elements of set A is equal to P, and number of elements in set B is equal to Q. As we know, students, relation is the subset of A cross B. If set A contains P elements and set B contains Q elements, then number of elements in A cross B will be NA into NB, and it is written here also, and this is equals to P into Q. Total number of elements in an A cross B, or you can say Cartesian product of set A and set B, will be PQ, and relation is the subset of A cross B. Total number of subsets will be 2 to power n, where n is the number of elements. So the number of elements here are PQ. So the total number of relation will be 2 to power PQ. And here formula is written, total number of relation is the 2 to power pq. Example is here. Let set A contains 1, 2 and B contains 3, 4, 5. Means number of elements in set A and set B is 2 and 3 respectively. So the number of elements in A cross B will be 6. That's why total number of relation from set A to set B will be 2 to power 6. It is the 64. Now students, let's see one more example. Let A contains xyz and B contains 1, 2. Find total number of relation from set A to set B. By the formula, it will be 2 to power pq, and by the observation p is 3 and q is 2. It is equals to 2 to power 6, and again it is the 64. Total number of relation from set A to set B are the 64. Students, let's see inverse relation, or you can say inverse of a relation. Let capital R, which is subset of A cross B, be a relation from A to B, then the inverse relation of R, to be denoted by R inverse, is a relation from set B to set A defined by B, A such that A, B belongs to R. Thus you can say, if A, B belongs to R, then B, A belongs to R inverse, where element A belongs to set A and element B belongs to set B. It is clear domain of R inverse is the range of R, and range of R inverse is the domain of R. Student, let us consider an example here. R is given by, a relation is given as 1, 2, 2, 4, 3, 6. This is the relation R. Now domain of R will be set containing first elements, means 1, 2, 3, and range of R will be second elements 2, 4, 6. Now inverse of the relation R is represented by R inverse, and this is written as B, A, means it will be 2, 1, 4, 2 and 6, 3. Now domain of R inverse is equals to range of R. Here domain of R will be 2, 4 and 6, and range of R inverse will be 1, 2, 3. And you can say, or you can observe here, that domain of R inverse is equal to range of R. Here you can write range of R, and similarly range of R inverse is equal to domain of R. Students, we shall study about one of the most important concepts in mathematics, known as a function. Students, function form one of the most important building block of the mathematics. The word function is derived from a Latin word meaning operations, and the word mapping and map are synonyms to the function. Students, function play a very important role in differential and integral calculus, which you will study in 12th class. So students, now we have to understand the basic definition of a function. Here is the function as a special kind of relation. As we know, what is the relation? Students, let's A and B the two non-empty sets. A relation from set A to set B is the subset of A cross B. As we know, this relation is called a function if there are two fundamental conditions. What are the conditions? First is, for each A belongs to A, there exists B belongs to B such that A, B belongs to the function. Students, second point is this: if A, B belongs to F and A, C belongs to F, then it is necessary that B equals to C. Students, the meaning of first statement is this: if a relation is called a function and it is defined from set A to set B, then each and every element of set A will appear in some ordered pair in function. And what is the meaning of point number 2? The meaning of point number 2 is this: no two ordered pair in function have the same first elements. What is the meaning of this? To understand the meaning of this, we have to understand, or you can say we have to take an example. Now students, let's see this example. Set A is equal to this, set B is this. F1, F2, F3 are the three subsets of A cross B. What is the meaning of subset of A cross B? They are maybe relation or maybe function. Then if they are function, then F1, F2, F3 must follow the previous conditions. Point number 1 and point number 2. Now check. It is the F1. In the F1, this is the 1, 2, 2, 3, 3, 4. Means all elements of set A will be first element of the ordered pair. It is 1, 2, 3. It is okay. Here 1, 2, 3. It is also okay. And here in F3, it is the 1, 2. Means 3 is not related with any element of set B. That's why F3 is not a function. It is not a function. Got it, students? Now for F2. In F2, what is the second condition? Second condition is this. No two ordered pair can have same first elements. But in F2, these two ordered pair are such that first element is same. That's why it is not a function. Now you have to check this F1. F1 follows all two properties, all two basic properties of the function. Now you can say the given subsets F1 is a function. Students, now you can understand function as a form of ordered pair, because function is a special kind of relation. And what is the relation? Relation is the subset of A cross B. And what is the A cross B? A cross B is the collection of ordered pair such that first elements come from set A and second elements comes from set B. Now students, a function from set A to set B can be expressed as a set of ordered pair in which first element of every ordered pair is a member of A. It is the first condition. And second element is the member of B. It is obvious. So F is a set of ordered pair A comma B such that A is an element of A, small b is an element of set B. And third important condition is this: two ordered pairs should not have the same first element. This is the basic fundamental conditions. Function as a special kind of relation is similar to how to represent a function as a ordered pair. Now here, let's see one example. Set A is given, set B is given, and from set A to set B, function is defined like this. This is the basic description of the function. Then find a function in the form of ordered pair. Students, let's see the solution. For x equals to 1, we have to find f1. f1 will be 2 into 1 plus 3 is equal to 5. Means ordered pair 1, 5 is generated. For x equals to 2, f2, it will be 2 into 2 plus 3, it will be 7. And for x equals to 3, f3 will be 2 into 3 plus 3 equals to 9. Ordered pair here 2, 7 and here 3, 9. Function can be defined as set of ordered pair, or you can say in the form of ordered pair. It is 1, 5, 2, 7 and 3, 9. Students, after the function as a relation, we are going to study function as a correspondence. What is the meaning of this? Let set A and set B two non-empty sets. Then a function f from set A to set B is a rule or method or correspondence. They are the similar terms which associates element of set A to the element of set B such that, what is the conditions? All element of set A are associated to the element of set B. And second condition is this: an element of set A is associates to unique elements. This is most important. Unique element of set B. Let set A is 1, 2, 3 and set B is 3, 4, 5. Then by arrow diagram method, you can say here 1, 2, 3, 3, 4, 5. If we are going to describing a relation from set A to set B, then it must follow the following two cases. Means each and every element of set A is associated with the element of set B. Let's 1 is associated with 3, 2 is associated with 4, and 3 with 5. Then it is okay. All element of set A are associated to the element of set B. An element of set A is associated to unique element. Means for 1, 3 is unique, for 2, 4 is unique, and for 3, 5 is unique. Suppose here is one example such that it is the set A and set B. The element of set A is related with two elements of set B. Then this given system is not a function, because for the one there is no unique association. Means one is associated with A and B simultaneously on the same time. It is not possible. Means this is not a function. This is the basic fundamental definition of the function. Let's see one more example. Suppose set A is here and set B is here, and here elements 1, 2, and here is only one element, and we can associate 1 with A and 2 with A. Then this can be a function, or you can say this is a function, because for 1 A is unique and for 2 A is also unique. I think it is okay, students. Got it? Now students, we can understand image and pre-image. What is the meaning of image and pre-image? If a function is defined from set A to set B, and set A contains elements A and set B contains element B, such that A is associated with B, then you can write B equals to f of A. And in this function, A and B have a property. A is called pre-image of B. Means if somebody asked you what is the pre-image of B, your answer will be A, and image of A is equal to B, or you can say f image of A. F image of A is equal to B. This is the basic concept of image and pre-image. Students, now recall it. A is called pre-image of B and B is called image of A, or you can say f image of A. Okay, students? Students, let's see one example. In this example, 4 functions are given. You have to check which of the following is not a function by the definition of a function as a correspondence, or you can say as a mapping. In this function, or you can say in F1, 1 is related with B, 2 is related with A, and 4 with C. It is not a function because there is no correspondence, no mapping of element 3. Means you can say this is not a function because 3 has no mapping in set B. It is not a function. For F2, all element of set A have an image in set B. It is okay. But it is not a function because element 4 is not have unique image, because element 4 is associates with C and D both at the same time. It is not possible. That's why it is not a function. In F3, all element of set A have the unique image and 2 and 3 have the same image. It is also okay. F3 is a function. It is done. F3 is a function, and F4 is also a function because in this each and every element of set A corresponds to the unique elements of set B. Means in this question you can say F1 and F2 are not a function and F3 and F4 are functions. Now we will discuss description of a function. Let a function f defined from set A to set B, then it can be written as f such that A to B. Now one thing is important. description of function is based on the set A tendency. What is the meaning of set A tendency? Either set A is a finite set or it is a infinite set. If set A is a finite set, let set A is equal to -1, 1, 2 and 3. Then you can say by the definition of function f minus 1 equals to 0 separated by commas, f1 equals to 3 by 2, f2 is equal to 4 and f3 is equal to 5 by 2. This is the simple description of a function. In this category, function is defined from set A to set B, where A is a finite set and B is maybe any set. But if A is infinite set, then what will happen? And how we can represent a function as a image form, or you can say as this form, listed form. Then how we can describe a function if set A is infinite set? In such cases, functions are generally described by a formula. For example, f such that z to z. As we know, z is the infinite set. It is the set of integer. Now, function is described by a definition or formula. For an example, fx equals to x square plus 1. This is the description of a function. Let's see one more example. F such that r to r fx is equal to e to power x. This is the description of a function if set A is infinite. Means description of a function can be categorized on the basis of set A. If set A is finite, then you can describe like this. If set A is infinite, then you can describe like this. And generally, and most of the cases, we have to follow this rule. Got it, students? Let's see number of a function from set A to set B. Now let there is a function f. It is defined from set A to set B. Then how many total number of function can exist from set A to set B? As we know, function can be described as a roster form, or you can say in ordered pair form. In this form, suppose there is an element x1 and x1 is related with, or you can say x1 is associated with any one of the elements from the set B. Means it may be either y1, y2, y3 up to yn. Means x1 has n option. Similarly, x2 have n options and x3 have n options. Means all individual elements have corresponding n options to associates from set A to set B. Means for x1, x2, x3, ... for xm, there are n options. That's why total number of association can be equal to multiplication of these numbers, or you can say n into n into n. How many times? M times. And this will give total number of functions from set A to set B. You can write here total number of function is equal to n to power m, where number of elements in set A are m and number of elements in set B are n. Let us see an example. Na is equals to 4, nb is equal to 3. Then we have to find total number of function from set A to set B. Then your answer will be 3 to power 4.